Hi, my name is Andrew Messier and I'm a member of the NetSim development team for Boson Software. I'm going to give you a video walkthrough of Standalone Lab 27 OSPF in Boson NetSim 8. I'll begin by double-clicking on the lab title from the Standard Labs tree, and after NetSim finishes loading the lab, I'm going to launch the external lab document viewer and drag it over to my other monitor, just so that I have more real estate for the topology diagram and the command line interface. Task 1 requires us to configure basic device and IP information on routers 1, 2, and 4. So I'll begin doing that on router 1. I'll start with the host name. Next I'll configure the IP address on Fast Ethernet 00. And enable the interface. I also have to configure interface serial 0/0. And the lab document tells us to configure a clock rate on this interface for router 1, so that tells us that this is the DCE end. If it did not tell that, of course we could look that up on our own with the show controllers command. And I'll enable this interface too. Next I'll move on to router 2 and configure the host name. And the Fast Ethernet 00 interface as well. And finally we'll move to router 4. And configure the IP address on interface serial 0/0. The final step in task 1 asks us to verify what we've did, and we're going to issue pings to verify that we can get to the directly connected neighbor. And I'm using the do command here to stay in global config mode. And all four pings were successful. So we're going to move on to task 2. In task 2, we are required to configure OSPF on all 3 routers. We're going to configure each one with a OSPF process 100. And we're going to give the explicit network statements and put those in area 0. And on router 2. The process ID for each one does not have to be the same, but the lab document asks us to do that, so we will. And that's all for task 2. In task 3, we're going to verify everything that we've done. So the first step is going to be to verify that we can ping our non-directly connected neighbors. So router 2 is going to verify that it can ping router 4, and router 4 is going to verify that it can ping router 2, because in order for that to work, OSPF will have shared the required information to build up the routing table for all 3 of these. success. And success here. And just to further verify this, we'll bring up the routing table on router 2, and we see that we have the 172.16.10 network, which is this point-to-point link right here. On step 3, we're going to bring up the show IP protocols. We're going to issue the show IP protocols command to verify that OSPF is running. We're getting information from both these devices, and it is running OSPF 100. The next step asks us to issue the show IP OSPF database command and observe the LSA database. We have information, again, only for area 0 because that's the only area that we've configured. We have 3 type 1 LSAs or router link states for each of the devices, and we have 1 net link state, which is the type 2 LSA for this broadcast network between router 1 and router 2. And we're also asked a question, which is how the router ID is derived. And the first thing that it looks for is the router ID command under the process, and if that does not exist, it will then look for the highest IP address of any loopback interface. And we do not have any loopback interfaces, so the third criteria is the highest IP address of any interface that is configured and up and up. And for router 2, that is the 10.1.1.2 interface. See, that is the only IP address configured on this router. In step 5, we're going to issue the show IP OSPF neighbor command and observe our neighbor relationships. Here, router 2 only has 1 neighbor, and that's router 1. The router ID of router 1 is 172.16.10.1, and that's why we see this here. We're asked what the full underneath state means, and this just indicates that router 1 and router 2 are fully synchronized and they are done sharing LSAs. So it means that their databases are fully synchronized. So all the information that router 1 knows, router 2 also knows. And finally, in step 6, we're asked to issue the show IP OSPF interface command to observe information about the interface. And we're asked another question, what does state backup indicate in this? And this tells us that router 2, this interface, Fast Ethernet 00, in router 2 is the backup designated router on this broadcast network. So router 1 it will actually have to be the DR, which is what we observed in the previous command, and this is the BDR, or backup. And that concludes Standalone Lab 27 OSPF. Thank you for watching.